What do I mean when I refer to the mess? You heard earlier with Beth talking about the Wild West of carbon. The market can be quite confusing. There's tons of terminology flying around in terms of the global voluntary carbon market, the energy transition, net zero strategies, carbon neutral. And so if I ask the room to define just all of the terms on this screen, how many different definitions do you think I'd get? It can be daunting to organizations that are looking to understand their environmental impacts and start to operationalize change within their organization and really start to set those goals for making change. That being said, I want to talk about some key terms today that you should really be aware of when you're looking to accomplish multiple goals and objectives within your organization. So before we get there, let's start from a common place of you've made commitments, what happens now? You've inventoried your organization through your scope emissions, you understand what your carbon footprint looks like within your operations, and you've started to utilize some of the strategies that Beth was talking about earlier, with looking towards the energy transition, decarbonization, to really make some of these reductions. But you've come to realize that in order to reach these net zero or carbon neutral strategies that your stakeholders want you to achieve, that you're looking to achieve to enhance the sustainability of your organization, there's a need for that remaining residual emissions that can't be reduced. That's where carbon credits or offsets really come in, or projects that have positive climate benefits. A great way to achieve multiple benefits for your organization is through nature-based climate solutions, or NbCS. These are projects that, for the purpose of today's conversation, primarily relate to restoration and conservation work with natural and semi-natural systems, and you're uplifting the function of that system to provide various benefits. Specifically within this application, this relates to climate change mitigation, so primarily avoiding emissions entering the atmosphere, reducing that over time, or removing emissions from the atmosphere, greenhouse gases, through a process called carbon sequestration. These solutions also provide many co-benefits as well, whether it be through improved air quality, water quality. It can be improved resilience, so you can engage in climate adaptation, help to protect your infrastructure. There can be benefits for human health and well-being, supporting the recovery of critical biodiversity, which, if you're not aware, the World Economic Forum recently identified biodiversity loss as within the top 5 greatest global risks. So there's a great opportunity to really engage with these types of projects to accomplish multiple goals and objectives for your organization. So where does Stantec expertise come about in this space? We have a growing group within Stantec, vast professionals that implement nature-based solutions globally across virtually every ecosystem on the planet. Tons of ecosystem restoration professionals. And a lot of the great work that's already been done to date, whether or not it's been accounted for, has been generating positive climate benefits, uplifting natural systems through the designs that we're implementing. So we have the team to engineer really resilient, productive ecosystems. We have folks like Dave earlier that have extensive experience looking at risk and being able to model risk on assets, and incorporating that sort of approach into these natural systems ensures that your design will remain into the future and your ecosystem that you are helping to uplift will continue to function as intended. We also have a natural capital team that's quantifying all of the various co-benefits that's associated with these projects. They look at biodiversity improvement, for instance. And we've already had some great presentations yesterday talking about ways to incorporate and look at social value and equity within projects that could easily be incorporated into these approaches as well. So oftentimes you see, when you see credit quality, you see high quality credit. Everyone who's selling credit or offsets in the market refers to their credit as high quality, but what does that actually mean? A good way to think about this is going from a system that is degraded. This is a system, Prime Hook National Wildlife Refuge in Delaware, so this is on the eastern coast of the US for our international colleagues. And this was heavily damaged after Hurricane Sandy. We had a great engineering team that went in and did a ton of modeling and design and implemented an extensive shoreline restoration project here. You can see that the beach system was broken through. It's inundated, tons of marsh system on the inside. It's posing issues for critical habitat for wildlife. It's also posing an issue for infrastructure. And from a carbon sequestration perspective, that wetland has lost a lot of its function. So we're going from this system that is not resilient, that's lost a lot of its function, to one that is functionally permanent, that's built to withstand future storm damage, rebuilding that beach system. And also by rebuilding that marsh system, it's now providing extensive climate change mitigation as well. So it's providing multiple co-benefits. So when we refer to high-quality credit, we refer to two things: permanence, meaning that it's going to remain into the future, and co-benefits, meaning that it's not just sequestering carbon, it's also providing multiple benefits for a variety of stakeholders, including our local communities. So where are we innovating in this space? I want to talk about two innovations today, one of which is our carbon credit tool, which our team has been developing. The intent behind this is to streamline the very complex carbon crediting process for a variety of different project types. So in order to certify the benefits that are generated from these projects, you need to be able to work through all the calculations, understanding the flux in and out of those natural systems. You need to understand your baseline, how that was anticipated to change and change over time as your habitat were to develop or existing land use strategies were to persist. And then you're implementing a strategy, and how is that now changing over time? And then, of course, there's monitoring to validate all of the changes that you projected would occur. This can be quite complex. This is just an example of a small snippet of one calculation step of one type of project. So the first step is really mapping out these protocols in a way that we can then build a tool around that's functional and that streamlines our calculation process. So all these pink boxes are functionally factors that were either derived from monitoring data or from primary literature. We have yellow boxes, which were oftentimes model parameters, equations in green, and all of those get combined together to calculate essentially one portion of what you need to know for a project. Another way that we're streamlining sort of our calculation approach with the tool is we're building a comprehensive spatial database. So we've conducted many primary literature reviews for various projects in different geographies. We're working on projects globally. And part of that is compiling this information in a way that can allow us to quickly understand a site's potential into the future using the data we've already gathered to date. So we're doing this in ArcGIS Online and building an app which has been developed so we can pinpoint a project's location and get a short list of all of the data that we've compiled to date associated with a certain mile radius of that project type, that habitat type, that can be really useful in understanding potential. So what's the application of this? Primarily, this really provides value from understanding that potential, which can provide value in screening a project. So we can look at a variety of different properties, a variety of different project opportunities, and we can better understand what is the potential. We can start to aggregate or group projects together, which can reduce the costs associated with monitoring and certification, and then ultimately optimize credit yield and that return on investment for our clients. And just kind of an example of that sort of approach. So this is the Louisiana, or a portion of the Louisiana Coastal Master Plan, which is in the Gulf, southern Louisiana coast. And these are all these projects that are planned to be implemented. And so we started to look at, from a high level, what is some of the potential associated with these projects? And then spatially, based off of where they're located in the project type, how could we group these projects together to maximize or optimize that potential? Another thing I want to talk about with particular value for large projects is how we're working with my colleagues Grant and Martha to develop CarbonWATCH. This is an opportunity to utilize remote sensing. It's object-based image analysis, high-resolution aerial imagery, LiDAR, to start to inventory carbon resources within natural systems. This allows us to conduct carbon inventories. We can look at individual species. We can monitor those species over time, individual plants, and we can also start to group those into categories. So we can tell you within a certain project area what is the carbon that's contained within those natural resources, which allows us to then show over time, as those resources grow and develop, if it was planted or restored, how much additional carbon sequestration is occurring. And then also if there are understanding or potential impacts associated with land use practices that are planned, we can quantify the carbon impacts associated with those practices. We can also map that out spatially. So in this example, this is a mine reclamation, so you can see each one of those trees really clearly that were planted. It's in northern Canada, so very slow growing, but we can monitor that growth over time and really pinpoint each one of those trees and as they develop, the value that's contained within them. In terms of soils, Martha's dissertation was fantastic. She really focused on being able to predict within a high level of accuracy soil carbon and map that out spatially. And so we're working to incorporate this into CarbonWATCH since soil carbon is such an important component for many of our projects, particularly with our agricultural projects and grassland projects as well. That being said, this is a multi-team, multi-geography, multi-business center effort. We have lots of support. Our tool was funded by the Innovation Office. We've received lots of support from my own business center, from Water and Environmental Services. We have a great and growing NbCS team. Obviously, the folks I mentioned that will be presenting in the next session with CarbonWATCH, and then lots of champions that have really supported the growth of our program. So let's get back to that mess. If there's one thing I want you to take away from this, it's the idea that Stantec is implementing nature-based climate solutions. We have the expertise to do this globally, and many multidisciplinary and talented staff to be incorporated into our project team. So with that in mind, if you're looking to accomplish multiple goals and objectives for your organization, let's clean up the mess with NbCS.